Hi, my name is Victor Cruz, and I'm going to talk about engines today. But before we talk about engines, since this project is about subsystems, what's a subsystem? A subsystem, according to Merriam-Webster, is a system that's a part of a larger system. I'm glad we got that out of the way. And before we talk about engines, we got to talk about what an engine's a part of, the powertrain subsystem. So the basic layout of a powertrain is the engine sends power to the transmission, which transfers that power to the drive shaft, which then transfers that to the differentials, which then transfers that to the axles. A lot of transferring of energy is basically going on here. Here's an example of a powertrain layout. Not the most conventional one, but essentially the motor spins, then sends power through a drive shaft to our transmission. This transmission is a special one as it's a dual clutch transmission, but also it's a transaxle. So the transmission and the differential are in one unit back here. But also this transmission has a transfer case, which then sends power through another drive shaft all the way to the front through a basically differential that's in this area right here to the front wheels. And the back differential sends it to the rear wheels, which gives the GTR this kind of higher hood line because it's got to sit on top of its diff and such. Corvettes use something similar. It all depends on the manufacturing, the car's needs of how the transmission is worked. Typically, it goes from engine to transmission. There's different types of transmission. You got manual, automatic, CVT, dual clutch transmission, as in here. They all do the same thing, just slightly different and for slightly different applications. Where does an engine fall into this? An engine is a subsystem of the drivetrain. Drivetrain is a subsystem of a car. So we have a subsystem inside of subsystem. So we got subsystemception here. There's different types of engines though. Like this longitudinal flat four, also known as the boxer engine. So it's a turbocharger. Or a 2-liter transverse 4-cylinder inline 4 turbo. Even a 3.5-liter dual overhead cam V6 that goes in a G35. Or a 3-liter supercharged V6. Or this 3-liter turbo diesel V6. Are inlines, which is all the cylinder and pistons are in line. V's, all cylinder and pistons are at a V angle. Rotaries, which just has a spinning Dorito. We'll talk more about that in a second. Flat engines, also known as boxers, popular with Subarus and Porsches, have the pistons going out this way, similar to a V, but instead of them being at like a 90-degree or 60-degree angle part, they're 180, which is just a line at that point. You got a hybrid systems, so it could help a motor create power or get better MPG, or the motor could just be charging some batteries. Different types of fuel, such as gas, diesel, or fully electric. We won't really be talking about electrics in this video. That could be a whole separate topic in itself. But how does an engine work? What's its basic principle? This is called the 4-stroke cycle. So essentially, you have 4 main strokes: your intake, compression, power, and exhaust. Most people know it as suck, squeeze, bang, and blow. So your intake stroke, sucking in air and fuel mixture. Compression stroke, compressing the air to fuel mixture. Power stroke is where your spark plug ignites and pushes the piston down, and then your exhaust stroke is you're letting out all that burnt fuel and exhaust out. Similar happens in a rotary, but since it's a basically a Dorito spinning at very high RPMs around the shaft, it can have the suck in air, compress it, ignite it, and let it out all in essence one motion. It's got these things called little apex seals, which help separate everything, but instead of it being four main cycles, it's doing everything at once. There are two main sections of an engine. With the example here having a blown apart LS9, a part of the C6ZR1, codenamed Blue Devil. You have the short block, which is your crankshaft, your connecting around your pistons, basically your basic rotary assembly. So your block and this whole section right here. You have your long block, which is a more finished product. So on top of just your short block, you have the heads, you have spark plugs, fuel injectors, your intake manifold or supercharger. You got your baffles, you got your pulleys and accessories, your alternator. Essentially, everything can be a short block. Well, everything has a short block, but not everything's a long block. As you saw, different types of engines, different ways to build engines. So, right, there's two main head types. You have push rods, which uses basically a rod to push a rocker arm that pushes a valve spring down, the valve spring and valve down to let air in or out of a cylinder. Or you have an overhead cam, which has a spinning cam that pushes down the valve and valve spring to let air in or out of the cylinder. The two things you notice that are similar about these two styles is they both have valves and they both have valve springs. Valve springs just help push the valve back up. As you see here, here's a push rod head out of the LS9. Very simple, while a overhead cam is basically more complex. We add more complexity with the overhead, but it can rev higher, it can be more fuel efficient, more manageable, while it's easier just to build a push rod head. But that's old technology, but only a few engines still use it, like the LS or LT engines from Chevy. There's three main ways to build a block. You have cast iron, you have cast aluminum, and you have forging. Cast iron is pouring hot molten iron into a cast, which creates a block. It's the cheapest way to do it. It's very heavy, but it can be very strong. While a cast aluminum, while pouring molten aluminum into a cast, is a little bit more expensive, but it has basically almost the same benefits as cast iron. But it's a bit lighter, so typically used on performance cars, luxury cars, or commuter cars where we have to keep weight down. Lastly is forging. Forging is the strongest motor option since you get a big piece of metal, you cut all the basically things that aren't a motor away, which leaves it the strongest block, but it's the most expensive, which is why it's typically just left for race cars. It's all about timing. And while we have talked about the four-stroke process, that won't be possible without timing. What is timing? Timing is the process where the fuel injectors, your spark plugs, your pistons, valves, and rod are all working in harmony to create power, and they're not getting in each other's way. They're all working as a perfect unified team. Without timing, you would have misfires, you wouldn't be making the power you need, your car would be running dirtier, as well as you could have a piston hit the valve and basically destroy your motor. Parts of the timing is the belt and chain, your camshaft sprockets, your pulleys, your tensioners, your water pump, and your oil pump. Your water pump helps send coolant through your entire engine to help keep it cool, while the oil pump sends oil through the entire engine to keep it lubricated. Right here, you have a part. Right here is a VQ35D rev up that uses a chain timing assembly. You have an EJ20, which uses a belt driven assembly. Both have pros and cons, but it's more to the manufacturer of which one they want to use. I will say chains are typically a stronger unit, but there are plenty of belt driven cars that make over 1,000 reliably. So it all depends on the manufacturer which one they want to go with. We're going to talk about my favorite thing, boost. There's two main ways to boost an engine: superchargers and turbochargers. Superchargers run off the belt and use two rotors to help compress air and send it into the intake, which goes through your valves and then into the four-stroke cycle, as we talked about. Turbos use the exhaust gas to help spin a turbine, which is connected to the shaft to spin a front turbine that sucks fresh air in, compresses it, and then sends it through a system of pipes into your intake. Superchargers are cheaper to make, cheaper to build, cheaper to maintain, and easier to install and give you instant power, but you got to sacrifice some horsepower to create more power. You got to give something to gain something. While turbochargers use a leftover exhaust gas from the engine that's already been created to help create more power. Granted, the system's more complex. You got to run more oil and coolant lines. You got to wait for the turbo to spool up, which creates lag to create the power. Also, they just cost more to build. But the pros are you're not sacrificing more strain on the motor to create more power. You're creating more power more efficiently, which is why there's so many commuter cars and supercars and stuff that use turbos because it makes power more efficiently. Lastly, we're talking about power, but power's got trade-offs, such as the more power you make, the less MPG you're gonna get. What's MPG? That's your miles per gallon. An EcoBoost might make the least power out of the entire Mustang lineup at this current time, but it has the highest combined 26 compared to the GTD making 850 horsepower 12. So there's trade-offs to power. There's trade-offs to all the systems we talked about. Some are cheaper, some are more expensive. Some make instant power, some you gotta wait a little bit to make the power. Some parts cost more to make than others. Some sound better than others. There's trade-offs to all of it. But as you can see with this chart, the more power you have, the lower your MPG goes. And also at this current time, Ford has now released the FP800's MPG. And we're talking about people regulating and giving out information. The EPA. The EPA are the people that control everything for cars. Mainly safety as well as making cafe standards, doing the Clean Air Act so cars don't make as much pollutants, that they make less CO2 gas out of the exhaust pipe and not as much pollutants going out into the world, hurting the ozone, hurting polar bears, trees falling over. All that stuff that, you might not want to breathe in. If they don't meet these standards, the cars just can't drive on the roads. These all have to conform to the same standards. There's slight differences given depending on what this vehicle has to do, as they will be strict on EcoBoost than they will on the GTD. Due to the GTD, they're only making about 3,000 of them, so they can't create all that much pollutants if there's only 3,000 of them compared to maybe 50,000 coming out of the EcoBoost. But it's just trade-offs. Do you want to get less MPG, but you'll probably get there faster after a stop or two. But your EcoBoost would be friendlier in the city, and maybe you just can't afford the gas of a dark horse. They're all trade-offs at the end of the day, and the EPA, we have to follow by them because we got to make it sure that, well, the exhaust, the gases, and all the harmful stuff are being collected by the equipment that the EPA has told us, such as catalytic converters, cleaner burning ignitions, fuel burn, fuel cut, idle minutes, everything that we've implemented in the cars to help with MPG or cleaner burning fuels and stuff are all controlled by the EPA. Thank you for listening.